Hello again, method students. We're going to go through exercise 2A in this video, which is all about linear equations. So just as a quick reminder, linear equations, we know ones where variables all have a power of 1. So you'll never see a x to the power of 2 or y to the power of 3 or square root of x or something like that. All the variables will just appear as a variable to the power of 1. So for example, 3x minus 4y equals 1 plus 2z is a linear equation with 3 variables. But something like 2m squared equals 5 or the square root of x minus 1 equals 0 is a non-linear function, or even something with like 5 over a in it, because that variable really is 5a or a to the power of negative 1. So solving linear equations, you will have done a lot of this over the last couple of years, but it's important to know how to do it and ideally how to do it quickly. To solve a linear equation usually requires use of inverse operations, but we also have to deal with things like expanding brackets, collecting like terms, manipulating fractions. So all important skills for methods, not just in this chapter, but throughout the whole year. So let's have a go at a couple. Example 6, solve the following equations. 6a has got some brackets on the left-hand side. You can see there's an x inside the brackets. We've also got an x on the right-hand side. So ideally what we want to do is get all the x's together on one side, move everything else to the other. But first thing we've got to do is expand the brackets. So doing that, we'll get negative 6x. Take away 8 equals negative 5x. Take away 7. We've got negative 6x on one side, negative 5x on the other side. We want to get them together. Doesn't really matter which side you move it to. It's kind of just personal preference. I like to get things to the left-hand side, x to the left-hand side, everything else to the right. So I'm going to add 5x to both sides here to get negative 1x. Take away 8 equals negative 7. Then take the negative 8 over by adding it, so negative x equals, so now I've got negative 7 plus 8 gives me 1, and divide both sides by negative 1 to make this positive x equals negative 1. Next one's got some fractions in it, so remember that if we're adding fractions together like we are in this equation, and we need to do that because we want to collect those x terms together, we need to have common denominators first. So one way to go about this is let's put the fraction over 5, let's make that have a denominator of 15, and of course make the other one have a denominator of 15 because our denominators were 5 and 3. Still equals 6 on the right hand side. So what did we do to each fraction to achieve that? Well, first fraction we multiplied the bottom by 3, which means we have to multiply the top by 3. Second fraction we had to multiply the bottom by 5, which means we have to multiply the top by 5 to keep it equal. Now we can collect that into a single fraction, so we can have 3 times x minus 4 plus 5 times x plus 1 all over 15 equals 6. So we can expand both of those brackets on top now to get 3x minus 12 plus 5x plus 5. It's all still over 15 equals 6. Now let's do 2 steps in one here. Let's collect these like terms together on the top, but we're also going to multiply both sides by 15. So collecting the like terms, we have a 3x plus 5x gives us an 8x. Minus 12 plus 5 gives us minus 7. Actually, I'll tell you what, I won't be lazy. I'll do it in a separate step. So keep the over 15. Now multiply both sides by 15. 15 times 6 gives us 90, I believe. Add 7 to both sides. 8x equals 97. Divide both sides by 8. We get x equals 97 over 8. That is a fraction, it's not a whole number. It can't be simplified. Sometimes that's just what your answer is going to look like. But x equals 97 on 8 will be the solution to that equation. All right. Also covered in 2A is solving worded problems, which often involve setting up a linear equation or sometimes multiple linear equations and then using the algebra to solve them. So if you are just given worded information, often what you would try to do is potentially draw a picture if that is going to help you break down the question. Define and assign a variable to represent the unknown value or values. Usually the unknown value should be the thing that you're trying to work out as the final answer. So if you're trying to find how much does something cost, let x equal the cost. We set up an equation and then we solve to answer the question. So let's give this one a go. Read it carefully. A hiker leaves their campsite and walks to a nearby town. Their average speed for this walk is 5 kilometers per hour. The hiker then walks back from the town to the campsite at an average speed of 7 kilometers per hour. if the total trip took 3 hours, how far away is the town from the campsite? So you may not need to do this, but for me, a question like this, it helps to actually have a rough little picture, like here's the campsite, here's the town. They walk from the camp to the town at a speed, or an average speed, of 5 kilometres per hour. So I'm just going to write that there, 5 kilometres per hour. On the way back, they walked a bit quicker. Their speed was 7 kilometres per hour. And the question is asking us, how far away is the town from the campsite? So in other words, we want to know this distance here. That's the thing we're trying to work out. So, given that we have speed, we have time, we have distance, why don't we let D equal distance from town to camp, or camp to town. And it's also worth knowing that, just as a relationship for anything to do with speed, speed will always equal distance over time. That's just a general rule. Makes sense, right? Because we always give speed in units of like kilometres per hour or metres per second. So speed is equal to distance over time. So let's try to set up our equations and see if we can solve something here. From camp to town, so let's say camp to town, the speed was 5 kilometres per hour. So actually, I'm just going to quickly write this down. Speed equals distance over time. Speed was 5 kilometres per hour. The distance we don't know. We also don't know the time, right? So we can put down from camp to town that, I think I wrote down there, camp to town. We've got this connection that 5 is equal to distance over time. There's not much more we can do with that just yet, but we've got that information. From the town to the camp, again, if we start with speed equals distance over time, well, this time we know that from town to camp, the speed was 7. So 7 is equal to distance over time. And again, with those two equations, there's not a lot we can do just yet. But what we do know is that the total trip, if we go back to the question, the total trip took 3 hours. So the time it took to do this part plus the time it took to do that part is equal to 3. So what we can maybe think now is let's rearrange these equations so that time is the subject. So let's multiply both sides by t, 5t equals d, and then in this case divide both sides by 5 to get time equals distance divided by 5. And for this equation, multiply both sides by t, divide both sides by 7, and we get time equals distance divided by 7. Now from these two equations, we have, I could even call this like time 1, time 2 if we wanted to label it that way, but we basically have the time for camp to town, the time for town back to camp. Together, those two things should add up to 3. So let's say something like total time, running out of space at the bottom of the page here, total time equals d on 5 plus d on 7, and that total time was 3 hours. So now we have an equation that we can solve for d. We've got, again, fractions being added together, different denominators, so let's put them both over the lowest common multiple, which is 35. So if we're going to make the first fraction be over 35, we need to multiply top and bottom by 7. Second fraction, we're multiplying top and bottom by 5. Still have equals 3 here. I haven't used my page very well, but let's just move this up to there. So adding those together, we would get 12d on 35 equals 3. Multiply both sides by 35. 3 times 35, well, 3 30s are 90, 3 5s are 15, so 3 times 35 is 105. So distance equals 105 divided by 12. Now both of those can be divided by 3, so we could simplify that down to 35 over 4. And we could just say that it's 35 over 4 kilometres, that would be fine. but we could also maybe write it as a, when we talk about kilometres, we're probably more likely to give it as a mixed number or a decimal. So 4 goes into 35, 8 times, 8 3/4 times. So we could give it as 8.75 kilometres, right? And that is our final answer to the question. So as you can see, worded problems do get a little bit tricky. They can get a bit messy, but it's good to draw a picture at the start if you can, if it's relevant, but also clearly define the variable that you're trying to solve for. I think that makes life a little bit easier. All right, long video, I know. Last thing that's covered in 2A is simultaneous equations. And again, this is something you've learned before, but important to sort of practice it and feel confident with it. So for example, 8 here, we've got a couple of different simultaneous equations to solve. Basically, you've got 3 methods for solving simultaneous equations. The 2 manual methods are elimination and substitution. The easy way, if you're allowed to do it, is on a CAS calculator. So for example 8, solve the following simultaneous equations by hand, then check your answers using CAS. This first equation, we've got 3x minus 4y equals 10. Second equation is 5x minus 4y equals 18. Because they both have a minus 4y in them, probably elimination will work nicely here. So if I call that equation 1 and equation 2, to eliminate the minus 4y, if we do equation, and we can do it either way around, but if we do equation 2, take away equation 1, we would get 5x take away 3x to give 2x. Negative 4y take away negative 4y equals 0. That's the elimination part of it. And 18 take away 10 gives us 8. And so we're just left with 2x equals 8. So of course x equals 4. And then don't forget, as always, you're solving for 2 variables in this case. So once we know x equals 4, sub that back into either one of the equations and solve for y. Usually you'd look for the equation that might be slightly easier, maybe because it's got smaller numbers. So let's sub x equals 4 into equation 1. And that will give us 3 times 4 take away 4y equals 10. 12 take away 4y equals 10. If we take 12 from both sides, we get negative 4y equals negative 2. So therefore y equals negative 2 on negative 4, which is a half. So therefore our solution is x equals 4 and y equals a half. And just make sure, because you're working, can potentially get a bit messy with simultaneous equations, make sure your final answer is nice and clear. All right, now if we're going to check that one using the calculator, I'll pop it on the screen here. Hopefully it comes up okay on the video. For simultaneous equations, you can, bring up your keyboard. In Math 1, you've got this template here. If you tap that button, that brings up the equations. If, by the way, if you had 3 equations to solve for, you just tap the button again. In this case, we only had 2. And the equations were 3x minus 4y equals 10. And 5x minus 4y equals 18. In this little button box here, you've got to tell the calculator what to solve for, separated by a comma. So x comma y. We get x equals 4, y equals 0.5, or if I pop that in standard mode, y equals a half, which is what we'd written down. Right, second one. This one might potentially lend itself a bit better to substitution. So again, I'm going to number these equations 1 and 2, but because the second equation has y equals, so we've got one of the variables as the subject of an equation, it makes that nice and easy to sub it into the other one straight away. So let's try subbing equation 2 into equation 1. And so equation 1 will just become x plus, instead of x plus y equals 5, it'll become x plus 3x minus 19. So x plus 3x minus 19 equals 5. 4x minus 19 equals 5. Add 19 to both sides, we get 4x equals 24. And therefore x equals 6. And again, sub that back into either one of the equations, whichever one looks nicer to you. Maybe the second one, because we won't have to do any rearranging. So sub x equals 6 into equation 2 to get y equals 3 times 6 minus 19. So y is 18, take away 19, y is negative 1. And again, we might just write our final answer clearly at the bottom. So if someone's marking your work, there is no doubt what your final answer is. And that one can be checked on the calculator using the same technique. And I should have probably clarified that going back to the very first example in this section, so things like example 6a, if you're just solving one equation on your CAS, don't forget your good friend solve. Very, very useful in methods. So like if we just go back and check our 6a example answer really quickly, you can bring up solve a couple of different ways. I usually use action advanced solve. You can also use solve from the keyboard. And -2, we were solving -2 times 3x plus 4 equals -5x, take 7. By default, your calculator will try to solve for x. If you're using any other variable, you would have to put a comma at the end of the equation. So say if we were solving for y, we would need to put comma y at the end. But for x, your calculator just solves that by default. That's nice to know. X equals -1, that's what we got. So we got 6a correct as well. All right, long video, I know, but a lot to cover in 2a and lots of important skills to practice. So get stuck into it.